Hello, everyone. Thanks for coming or staying. The next talk is from Steffen Pingel. He works at Tasktop Technologies from British Columbia, Canada, Vancouver, British Columbia, but is originally from Stuttgart. So, applause, please.
Thank you very much. And welcome, everyone. So I work for Tasktop Technologies in Vancouver. Thank you. And we're the company behind the Eclipse Mylyn project, which I want to talk about today. And that's very related to the talk that we saw previously. And then we're going to look at the IDE side of the story and how you can integrate those tools that we saw and use them in your process. So we saw that a lot of people are really using Hudson Jenkins. Who's using Git as a version control system? So that's 25% maybe. Is anyone using Gerrit as a code review system? 1, 2, so very few people. Okay, that's great, because I'm going to show you how you can interact with those tools and how they can help you in your development process. So around a decade ago, Mick Kirsten, the founder of the Eclipse Mylyn project, was involved in SPECJ, and that was and AGDT, and that was one of the project that adopted the principles that Kent Beck described him in his book. And in that project, they had Outlook to track some of their project. They're using Bugzilla to track some of the defects. They had Excel maybe for burn down charts. They had a lot of communication in email, while their day-to-day development was really happening inside of their IDE. In this case, that was Eclipse. And what you can see is that even though all these different systems are important for the development process and track different aspects of our project, they aren't integrated in our development environment where we do our day-to-day work. And that was one of the motivations for Mick to start the Mylyn project. And if you look at that IDE, here's just a screenshot of Eclipse, you can see that it does a very good job of showing us the compiler-centric view of the system. So in a typical workspace, we have a couple dozen projects, we have a couple hundred classes, thousands of methods, and you can see that entire structure in your workspace, and you get instant access to all the different parts of your system, even instant access to the JDK, which has another couple thousand classes in it. IDEs are very good at providing us access to all that information. But when you think about it, as developers, we usually work on a particular story. We want to implement a certain feature. We want to fix a certain defect. We usually only ever care about a handful of classes to get that thing done that we're currently working on. But yet, we see all this information. So basically, 9% of what we're typically seeing in the IDE isn't relevant. And this information overload causes a lot of distraction. And a lot of times, we're not just working on one thing, but we get interrupted. Somebody comes into our office, wants something, then you have to switch to a different task, and we lose that context. And when we continue where we're working on previously, then we have to rebuild that context. And so we end up spending a lot of time multitasking, going back and forth to different applications. We spend a lot of time searching, browsing for those different things that we need to do whatever we're trying to achieve. And we spend a lot of time handling interruptions. And all the different communication around our project ends up in our email inbox. All the Bugzilla notification about some change that somebody made to a bug ends up in our email inbox. And we spend a lot of time processing that. How much time do you think do we spend on those type of activities that are not writing source code, not writing documentation, not writing tests, but that are searching, browsing, navigating? Any guesses? So, any guess? 50%? Yeah, that's pretty close probably. It depends a little bit how you measure and what you consider waste, but there was a study was done in 2006 where they looked at the different activities that developers do. And it actually turned out that it was pretty close to 50% basically is wasted in our day. And this friction that comes from this lack of integration and this distraction that comes from the information overload, that makes us unhappy. And we're really most productive when we have this feeling of flow. When we think about when you last played your favorite musical instrument, that feeling, or when you last crossed the Alps on a bicycle, when you just have this one activity that you're really focused on and everything else around you disappears. That's when we're most happy, and that's when we're most productive. And that's kind of what Eclipse Mylyn is about, helping us to have a little bit more fun while we're writing software. And we want to achieve that by eliminating all that waste that we saw in the previous slide. All right, so let me switch to Eclipse and let me show you how it works in practice. All right, so this is my Eclipse. The first thing that I have to do in Mylyn is configure my issue tracking system. So I use Bugzilla, but works the same way for Track, Jira, and a number of other systems. Basically, provide the URL, provide my credentials, and then I can use this task list, which is the central view that Mylyn contributes to Eclipse. In the task list, I set up queries, and queries are basically my personal view on that repository. So in this case, it's the Eclipse org Bugzilla. I have selected all the Mylyn projects. I've said I want to see all the bugs that are assigned to me. When I run this query against the server, it brings in all those different tasks into my Eclipse. So and I can access them instantly. So if I double click one of these tasks, the editor opens immediately. That's because all this information about the task is cached offline. I can see all the little details, the milestone. I can edit it, move things between projects. I can add new comments here. I can save this. You now see that this has a little outgoing arrow, so I can make drafts, and then only once I do submit, this actually gets transmitted back to the server. I get things like hyperlinking support. Maybe let's see if we have a task that has a stack trace on it. So if there's a stack trace, I can just click on it, and it'll instantly navigate to the code. So I don't have to go and copy and paste that back and forth from my web browser. I can interact with the attachments, download attachments. I can easily attach screenshots. If I detect a problem, I could say, okay, there's something wrong here. Could highlight it, and then attach that to the bug very easily. Maybe somebody else would look at it. I get all the different things. I get a quick outline to navigate in the task. I even get some rich editing support. That's simple wiki syntax where I can have just a little bit of formatting, very simple. And of course, I have content assist. If I want to link to a different bug that's maybe related to search, then I can just type search at content assist and then enter that bug reference, click on it, and instantly navigate to it. In my task list, you can see it's very easy to bring in those tasks. I have set up another query for somebody I collaborate with, so I end up with a lot of tasks in my task list. So I can use the scheduled presentation, just a different presentation for the same list of tasks, and that's sorted by day. So here I can use drag and drop to organize my workday. So down here, I have all the tasks that are in my task list, and I can just take them and say I want to work on this next Monday maybe. If I don't get to these items that are scheduled for today, they automatically move to the next day. So I never lose track of them. If I complete them, they disappear from the list because they're done. If I know I have a hard deadline on something, maybe a release date, I can also set a due date. And if that task is assigned to me, then you can see this little decoration here now. And this task is actually displayed on top of my list because I know this is the most important thing that I need to work on next. All right, so now let's switch to the Java perspective. If I actually want to start working on a task, I use this activate task button here on the top. Activating task just means I'm now working on it. Let's close this. Let's get some space here. So I might look at a few classes here, navigate to the code. And now watch what happens here in the Package Explorer when I press this focus button. It now filters my view on my workspace just to the things that I've interacted with. So I can always go back, see everything. Now I just see the stuff that I actually touched. So as I now go down in this list, maybe open a class, it gets automatically added to my task. Add things explicitly, I can use this little plus hover, and as I click things, they automatically become part of my task context. What's really interesting, I can also use this task context is used in all kinds of different places in Eclipse. So if I use content assist, for instance, you see this separation line. It actually shows the stuff like extract mapping that's part of on top of the list. So I don't have to spend time going down the entire list, but I get the things that are most important to me on top of the list. And I can instantly add this in here. So now let's see what happens when we switch tasks. So let me go back to my task list. So maybe at that point, somebody comes into my office and says, here, I need you to look at this bug right now. So what I can do is I can deactivate the task that I'm currently working on and activate that task. Look at whatever is relevant for that particular issue. And then if I go back to my previous task, it instantly restores that task context that I was working on before. I now see that context again. It restores all the editors and takes me exactly to that place, to that editor that I was using before. So with just a single click, I can instantly switch back and forth between those different tasks, and this context gets automatically tracked and restored. So I don't have to think about where I was, but I can just continue to work where I would previously left off. And in this task editor, I also get this context tab where I can review the context and I can mark things as, oh, no, I can't. But the more that I interact with certain elements, the more that I edit a certain method, the more important it becomes. And at some point, if it's very important, it actually becomes a landmark. So I guess I have to activate the task. And then I can also manually say, this method is particularly relevant for this task, and then it goes bold. But if I had spent a lot of time editing that method, that would have just happened automatically. And on the top right here, top left here, I get the slider that allows me to manipulate the threshold for that degree of interest. So the further right I move the slider, the higher the threshold. So now only very important elements get displayed, and the further left I move, the more I see as part of that task context. I can remove things. Maybe something wasn't that relevant to the context. Also, if I don't interact with something for a long time, it gets removed from the context because it's not really relevant to that particular task. And so that way, the context always just contains the relevant items, so it stays reasonably small. When I'm happy with that, and maybe I'm halfway through resolving this bug, I can take this context and I just click attach context. Then it gets zipped up and put as an attachment on my Bugzilla bug or a track task. And somebody else in a different workspace can just download that context, and they would see exactly that same filtering view of the Package Explorer, so they would instantly know what's relevant, and I've automatically captured that knowledge on the task. And even if I go back to this, working on it 2-3 months later, I always know what the context was for this bug. And if I activate a task, let's look quick maybe, let me just clear this context, that has a context from somebody else already on it, then I can optionally just download it to my workspace and just work on that context. In this case, the bug actually had a stack trace on it, and a context already got automatically created for me based on that stack trace. So I know exactly these are the elements that are in the stack trace. If I now wanted to work on it, I wouldn't have to find them. Of course, I could click on them here, but I also see them here in my Package Explorer. And we call this extension to the Eclipse IDE the task focus interface, because it provides that task-based focusing. So, but as developers, we've seen how this works, how this integration works for Bugzilla, and how it works with Java. And by the way, this works the same way for C code and for PHP code. There are all kinds of different bridges and connectors that lets you use that same task focus interface with different languages. But we're not only working on alone in our IDE and collaborating over Bugzilla, but there are a lot of other pieces involved in our development process. I want to look at how this process works when somebody else proposes a change to the Mylyn project, at least how we used to work in the past. And I think it's typical. I mean, we work the same way internally at Tasktop. A lot of open source projects works that way, that somebody comes along, wants to change something or wants to implement a new feature, and they start by attaching a patch to the Bugzilla of that project, and then somebody else goes in, grabs that patch, applies it to its local workspace, builds it, finds out that maybe there's a problem in the patch, maybe it doesn't even build, goes back to the contributor or to his colleague and says, can you please get me another iteration of this? And then somebody else goes in, follows the same steps, grabs that patch, applies it to his local workspace, tries it out. At some point, maybe it ends up in our version control system, maybe it's Git, triggers off a Hudson build, and that build fails. Because maybe we weren't running all the integration tests, but we were just running some part of the test suite, or just a different environment. So build fails, we have to find out who caused that problem, have to go back all the way to the person who originally proposed the patch. And then we reiterate over this whole process again. And obviously there are a lot of manual steps involved here. We might end up with failing builds. We get very late feedback between the time where that person proposed the patch and where he actually saw that build failing. It's a lot of time passed. And these systems are pretty much disconnected. So this obviously causes a lot of accidental complexity in our processes. And that's the type of complexity that we can get rid of if we automate some of these processes. And we recently added some integrations to the Mylyn project that support that kind of integrations for Hudson, Git, and the Garrett code review system. And I want to show you in a demo how these systems play together. So I have another working set. Working set is basically just a way to group different projects and queries in my task list. So if I work for multiple customers, that's a very simple way to organize my workspace. So I can use the same workspace, but can switch back and forth between different sets of projects. This is a simplified workspace. It's a very simple project that I'm going to use for this demo. Let me delete this because I don't want a local task. All right, so I have a local Bugzilla set up here. I have a hello LinuxTag task that I'm going to submit to my local Bugzilla. I'm going to schedule it for today because I want to work on it now, and I'm going to activate it. My main class in this project is called app. So I previously showed this demo at the Rheinjug. It's outdated now, so it should be LinuxTag, obviously. And now, this project is in a Git repository. And if I now commit this, I automatically get this commit message that is based on my active task. So I see the bug ID here, and I see the URL to that bug. And I could even open it, so I get hyperlinking support, and then we should see that. You can see it open in the background. So I get this automatic traceability for that change that I just made. So it's now, I didn't have to type anything, but it's already linked to the bug report or to the task that I'm working on. So I'm not going to change that message because basically I usually track all the activities on the task anyways. So this should be in my, it's committed to my local Git repository. Now, since this is commit only local now, it's a distributed version control system, I have to push it to the upstream. Now, it's in my shared Git repositories that my team members also use. And this should have kicked off a Hudson build. And I have this builds view here in Eclipse. That's also provided by Mylyn. It has the same idea and works with Hudson and Jenkins. So I basically provide the URL. I select the build jobs on the server that I'm interested in monitoring. And then I can set it to automatically refresh, which I haven't done, but I can also manually refresh, and I now see that this change that I made actually caused the build on the server to fail. I get this little pop-up notification here in the lower right corner. I can open it. And similar to the task editor, I get a rich editor for accessing all the build details. I can see the console output, for instance. I see it's a Maven build. I can look at the changes. I see that it's exactly that change that I made. And I see my test results. I now see that apparently it's a test failing. So let me open this in the JUnit view. So now this takes the results and shows them here so that I can see what the actual problem was. Okay, apparently I changed the message in the application, but I didn't update the test accordingly. I can even rerun this in my local workspace, which should give me the same result. And yeah, obviously the message that I'm expecting isn't valid anymore. So of course, I should have probably run this locally, but sometimes developers forget, or sometimes it just takes too long. So it's sometimes easier to just commit something and let the server do it. Okay, now that it works, I want to actually update this commit. I'm going to push it back to the server. And now if I refresh, I can see that I get this little green arrow decoration here, which means the build is now running. And hopefully, after a couple seconds, it should complete, and hopefully it should be green at this point. Okay, perfect. So the thing that I didn't say here is that this isn't just a Git repository, but it's actually a Gerrit server. And Gerrit is a code review system that's tightly integrated with Git. And it basically acts as a proxy around the Git repository. To the outside, it just looks like a Git repository. I can push to it, I can pull from it, works the same way. But every time I push a change to a certain branch in Gerrit, I get an automatic code review generated for that. And we have some integration for Gerrit that works very similar to that Bugzilla integration. And I have a query for that. So if I refresh this in my task list, I can access this code review, and I now see it's that commit message that I provided. And I see the different Hudson builds that were automatically triggered by pushing to that Gerrit server. I see that this first build that I did was unstable. Then I updated the patch set, and then I got a successful build. And I can actually see the different iterations of this change here. So now, of course, code review makes the most sense if I don't review my own changes, but I get someone else to review it. And if we look at the requirements, we actually need a +2 from somebody else to approve this change. So what I'm going to do is I'm going to add Alice to this review. Now Alice gets a notification, and I'm going to switch personalities and actually close this workspace and open Alice's workspace. Set up in a very similar way. Also has a query for my code reviews. So I can open it so that in this case, it's basically give me all the open code reviews from the server. And if I synchronize that, meaning show me what has changed, I now get this blue arrow with a question mark, which means here there's a new code review on the server. And now I have the same Git repository here in the workspace. So if I wanted to try this change that Bob did, I could just say fetch, and then it would take that change, put it into a branch, and maybe if there was a new feature implemented, I could just invoke the application, try out that feature, provide feedback, but I can also look at the sources, of course. So I get this tree view of the change, make it a little bigger. I see that the change that Bob made, and right here from the editor, I can add a comment. Say this looks good, maybe. Also see the change to the test that Bob made. So this looks all very reasonable. And if I'm happy with the change, I can vote on it. So now, under review, all the requirements for that review are satisfied. I have the +2 vote under code review. I have that +1 vote that was provided by Hudson because the build was actually successful. And now, once I do submit, the Gerrit server takes that change and merges it into my master branch. And now if I switch to the master and I do a pull, I actually see that this change is now merged into master. And at that point, usually I would close off the Bugzilla bug. I would probably attach the context so that when I go back later to that task, I have everything in there. And we saw that traceability for the commit message, and we can now, if I look at my Git history that has this change that we just merged, I get this open corresponding task item, which then should, based on that commit message, it can automatically take me back to that task, and I can instantly see the change that was made, or the change that was discussed on the task. All right, so this is just an illustration of this workflow where we push the commit to Gerrit, and what Gerrit really does in that case for every change that I push to Garrett, it puts it into a separate branch. So in this case, Hudson validated that change in that branch, provided me feedback, validated if that change made sense, and then others reviewed it. But only after the review is approved and is actually submitted, only then does Garrett put it into the master branch. And so only then it becomes visible to somebody else. And since we already validated it, we know that it probably works. The tools that we saw are part of the Mylyn Application Lifecycle Tools project. The Mylyn started in 2004 as a technology project on Eclipse.org, or 2005 maybe, and then migrated to tools and is now a top-level project, which means it's on the same level like web tools or the Eclipse platform. And it's composed of several sub-projects that cover different aspects of the application lifecycle. We saw these different sub-projects in action. And each of these sub-projects has a framework component and then reference implementations that provide integrations with service systems or with different languages or other Eclipse parts. So we saw the Bugzilla integration, but there's also one for track, and we saw the context integration that provided that focusing for Java. But as I said, works the same for C, C++. On top of that, there's a rich ecosystem of extensions. Some of these are open source, maintained by communities. Some of these are commercial closed source. And they enable you to connect to all kinds of different systems that you might find in enterprises. The whole Mylyn project is really built on community. Right from the start, this has always been a very important part of the project, that we are open, that we're transparent, we value feedback very highly, and we have a very active community of contributors who provide patches or code reviews to the project. And I can only encourage you, if you're interested in trying out Mylyn or if you're already using Mylyn, please let us know if there are any problems. Please provide us with feedback through our news groups, through our Eclipse Bugzilla. And if you're interested in contributing, there's lots of documentation how to get started. And we have that infrastructure that I showed you, this automatic validation and the code reviews. We all use that within Eclipse.org, and you can just use that same workflows. Yeah, that's pretty much it for me. Any questions?
Hello. I've seen that when you have an issue and you can, Mylyn will remove all the information that you don't need to resolve this issue with the context, and will show only the classes that affected that issue. That information is managed by your SDM or by Mylyn? Where is it stored? Because if I change my Eclipse and I'm going to home, I will maintain this information, or I must export some file to my home Eclipse?
Mm-hmm. Yeah, that's a good question. So by default, it's only stored in your local workspace, or it's only ever stored in your local workspace. So there's a .mylyn directory under your .metadata directory that has all the contexts for the different tasks. But if you want to share it, then you can attach it on the Bugzilla bug or on the track task. In the task editor, just by clicking this attach context, then it's basically an XML file that gets zipped up and put as an attachment on the task, and that's where you can persist it.
Thank you.
Anyone else?
Sorry. Well, if you attach that file, does it work on other systems like Jira or somewhere else, or only on Bugzilla?
That works for pretty much all that slide that showed the different connectors. It works for all of them.
Also, for the code review, do you support any other system than Garrett?
That's a frequent question that comes up. That integration that I showed that has this tight Git coupling and this automatic validation with Hudson, that type of stuff that only works with Gerrit, to my knowledge. But there are other connectors available for Review Board, for instance, that also supports other SCM systems. And that IDE integration, that Eclipse integration for Review Board works the same way as the Gerrit integration. So you can access the code reviews right from the IDE. And then there's another project under the Mylyn Reviews project called R4E that stores the review model in files, and it's basically SCM agnostic, or it has connectors for different SCM systems. So it's a client-side solution that doesn't require a server, so that's also an option.
Okay. Any other questions? Okay, thanks.
Thank you very much.
There's going to be a break until 4 o'clock.